Awesome, and we are back, everybody. This next speaker is somebody that many of you guys probably know because he's been building one of the largest protocols in all of crypto the last few years. The first time I actually met this gentleman was a few years ago, back before EigenLayer had started, and I didn't understand what it was, and so I ignored it, and I ignored him in my Telegram DMs, and that was definitely a mistake. And so I recommend you guys learn from my mistakes, you guys listen up to this next talk, because next up we've got Sreeram talking about supercharging AI possibilities, the next frontier in crypto. Thank you, everybody.
Hey. Hi, everybody. Super excited to be here. I'm Sreeram, founder of EigenLayer, founder and CEO at EigenLabs, which is the company building the EigenLayer protocol. Today, I'm going to be talking about what is the role of crypto x AI. Is this really a thing? Is this a scam? What is going on? What is the fundamental thesis? Where are we today? Where we can go? And what role Ethereum and EigenLayer can play in this? OK, so first I want to open with, is this really a thing? Is this crypto AI really a thing? Is there a thesis for why we should be taking this very seriously? On the one side, we have crypto, we're all building here, has an apps problem. You know, we say, where are the users, where are the apps? What is the utility of this whole thing? Is it just meme coins, financial nihilism, and speculation? Is there something more? Crypto has an apps problem. AI, on the other hand, people building very interesting new intelligences, has a trust problem. How do you trust these things? How do you trust what this AI agent says? How do you trust this whole paradigm? So I think there is a match made in heaven between crypto and AI. Crypto can bring trust. AI can bring intelligence and applications. One way to think about it is agents are the new apps. If agents are the new apps, bringing agents and crypto together can solve each of those problems. Another way of thinking about it is a very technological lens. Think about what is AI, general intelligence. On the other hand, what is crypto? Crypto is unstoppable computers. If you can take unstoppable computers and mix and match them with artificial intelligence, artificial general intelligence, you will get unstoppable artificial intelligence, which is a crazy, interesting, new, novel combination. So I think we should take this seriously. Is unstoppable intelligence going to work in human interest? How do we make sure that these systems are useful and productive? The other aspect of it is AGI and blockchains. Blockchains are verifiable computers. Can we build verifiable intelligences? Trustworthy, verifiable intelligences. OK, that's the high-level vision. I think there is something here, both at the technical, technological level, as well as at a product level, right? Crypto market cap is $2 trillion. AI market cap is $10 trillion. When these meet, you can actually get real ignition. But where are we today? Why do we see so much skepticism among the crypto people of the agent thesis? Because, so first let's take this example. What do we see today when we see on-chain agents showing up? What are these on-chain agents? Basically, an AI agent hooked up with a crypto wallet. You give an Ethereum wallet to an agent and say, oh, this is the on-chain agent. But really, it's not that different from connecting an AI agent with a Web2 hook, like a Stripe API. OK, is this what we're here to build? A centralized agent running, interacting with Ethereum? Is that the interesting thing? I don't think so. This is neither unstoppable. You can shut down this server, and then the agent dies. Not verifiable. You don't know what this dang thing is going to do. In fact, it has a private key. If you try to give money to the agent to trade or something, you can lose your money. This is custodial technology. We're not here to build that. Definitely not here in Ethereum. OK, so what can we do? Is this even theoretically possible? So the first thing to observe is smart contracts are unstoppable and verifiable. This is really Ethereum's contribution to humanity. How do you build unstoppable, verifiable code? Take a code, write it, throw it on top of Ethereum, runs on its own, runs as predicted. That's why EigenLayer, the host was mentioning today that he met me before. The first time I came to ETHDenver 3 years back, I didn't even know you need to have a ticket to come into the main event. I was standing outside, tracking down people with, looking at their T-shirts and seeing, which company they're from and seeing if they will listen to me. And today we're here, one of the main sponsors and one of the biggest protocols on Ethereum. This is possible because Ethereum's unstoppable, verifiable, and we can just build a protocol, throw it on top of Ethereum, borrow trust, and scale it to tens of billions of dollars. It's not possible without that. Can we actually accelerate that by saying smart contracts actually become smart? They don't have much intelligence. You can put code inside it, but it's not that you can't put expressive, complex code in it. But theoretically, you can put a little bit of AI inference code in a smart contract. And theoretically, it's possible to build unstoppable, verifiable AI. Another way of thinking about it, smart contracts are the minimum viable agents. Right? Smart contracts, they just run on their own, and they do stuff. And so, can we actually make them really intelligent? They're just not practical today, because you can't write AI inside this. But here is our realization and why we are super excited at EigenLayer. EigenLayer makes autonomous, verifiable AI practical. Not just possible, but practical. I'm talking about 2025. You can have unstoppable, verifiable AI agents. OK, how do we build this? So the first thing about EigenLayer is, what do you build on top of EigenLayer? Everybody knows EigenLayer may be staking, restaking, something like that. But restaking is just the starting point of EigenLayer. The core idea of EigenLayer is to be able to build the verifiable cloud. You should be able to deploy applications on top of this cloud and be able to use services. We call these services autonomous verifiable services, AVSs. They are the ones that absorb the trust from the ETH staking and other staking that happens on EigenLayer and get these services, which are complex infrastructure services that can serve any application. So why do we call them AVSs? Autonomous, because they run on their own. You can actually continue running this service. You don't need to trust anybody, because anybody can put up more ETH and continue running these services. They're verifiable because if the stakers go rogue and try to attack the protocol, they're going to lose their deposit. So that makes them verifiable. OK, so now that's the paradigm. The paradigm is anybody can come and run this service, run it in a way that's unstoppable, autonomous, and verifiable. Now you can start offloading intelligence. You can think of decomposing. So you look at it here. There is a smart contract of the AI agent sitting inside an Ethereum smart contract. And this smart contract, unlike agents today which have a private key, and they can rug you if you lose your private key. Instead, these smart contracts, of course, don't have any private keys. What you do is you say, hey, here is a smart contract of an AI agent. The smart contract takes actions if they are certified by this AVS. The smart contract takes actions if they're certified by this AVS. And you move the inference off-chain, but it is still verifiable on-chain. This is a massive transformation. Now you can think of this factorization. You can have an on-chain contract on Ethereum which just does the basic bookkeeping, maintain assets, and so on. Off-chain, you run this AVS, runs all the time autonomously and verifiably. OK. What can we do? Now you can just run inference as an AVS. Verifiability because of the slashability by EigenLayer, and data availability. When an agent runs, it produces a lot of data. You need to have this data be public. You need to have this data be public for anybody to verify that the agent did what it said it did. So this is called data availability in Ethereum. And EigenDA is the most scalable data availability layer. 50 times what Ethereum's blob store can do today, 10x any other data availability layers you may have heard about in the market. OK, so EigenDA is a hyperscale data availability layer. What we did, we didn't invent this technology for scaling DA. We took Dankrad's Dank sharding, which is on the Ethereum's roadmap, just built it out of protocol. We discuss a lot here. In ETHDenver, the main topic that I see is how much can we accelerate Ethereum? Is Ethereum going too slow? No, you can build any service imaginable as an AVS today and accelerate Ethereum. This is my call to all of you. Go build new interesting things as AVSs, including AI. That's what this talks about. There are other ways to do verifiability, using, everybody re-executes everything. In fact, you see, people say, oh, Solana is very scalable. We don't need this Ethereum modular roadmap, all this stuff. Is it really? Can you run hundreds of thousands of AI agents on Solana? You cannot. You cannot. You need hyperscaling. We need hyperscaling. You cannot achieve hyperscaling when you have redundant execution. Every node does the same thing in Solana, in Ethereum today. But in the roll-up era, what we are planning for is to not have every node run everything. Already using EigenLayer and EigenLayer, you can actually achieve it. OK. When you think about these AI agents, an agent is much more than just AI inference. What is an AI agent? An AI agent is something that can actually take actions, not just be intelligent, but be able to take complex actions. When you think of these AI agents, when you want to build a verifiable AI agent, you need to verify not just the model, but every dependency that it has. If you don't verify these dependencies, you really don't get a verifiable agent. This we know, right? For example, we say Aave is a verifiable smart contract. But if its dependency, an oracle, is not verifiable, then of course, the smart contract is not verifiable because you can get rugged by the worst of the things that you trust. So if you want to verify an agent, you have to verify the orchestration, the model, the tools. This is the agent runtime picture from Anthropic. And what we've done is think about how to actually make it verifiable. OK. Now that you have this verifiability, what can we do with it? You can actually mix and match components to build really, really, really powerful agents. I said really 3 times. I mean, not just for effect, but I really mean it. So what do I mean by really, really, really powerful agents? And they're verifiable. They have a brain. OK, what is the brain of an agent? You know, we think and like come up with concepts. It's about inference. You're running, predicting what needs to be done. It's about training. You need to train, update your model. It's about collecting data. See, it says verifiable in each one of these. Why? Because if an agent trains and updates itself and it's not verifiably updating itself, you can get rugged. So you want to make sure every single step here is verifiable. Verifiable inference, verifiable training, verifiable data, verifiable benchmarks. You want to know whether Grok 3 is better than ChatGPT. How do you test this? You want to test an agent like an operator, from OpenAI. Is it better than some other thing? How do you know these benchmarks? Is Llama 4 better than Llama 3.2? How do you test these things? Verifiable benchmarks, GPU markets. This is the brain. But brain is not enough. You need sensing. You need the ability to understand what's going on in the world. You need a mechanism to understand what's going on Twitter, what's going on inside your Uber app, what's going on in the real world. In here at ETHDenver, you need real-world oracles. You need application oracles. You need internet oracles. All of these, every single one of these boxes already being built as AVSs, Autonomous Verifiable Services on EigenLayer. We have 100+ AVSs being built in 50+ categories. Each of them a core new infrastructure service. So what we saw when we entered into the space was anybody who's inventing new infrastructure had to build their own layer 1. So sometimes we joke here in Ethereum about alt L1s and so on. But there is a necessity when you want to invent something new, you have no place to express it. You have to find a way to express it. And that's what the whole alt L1s were. But what we've done in EigenLayer is let innovators invent something which is as fundamental as a new layer 1, but don't have to reinvent the wheel on all the other things. Just build the new thing that you're building. Is it inference that you're building? Is it training that you're building? Is it a GPU market that you're building? Is it an internet oracle? You can build all of these things on a common security substrate. That's what EigenLayer does. What you can do is mix and match all of them on EigenLayer. Now, this agent, which has the ability to perceive and has the brain, also has the ability to satisfy intents. Normally, when you think of intents, you say like, oh, maybe humans have intents and AI will satisfy it. But it could also be the other way around. AI and agents have intents, and we satisfy it. So it can put out bounties that we go and satisfy. It can have privacy layers, trusted execution environment, fully homomorphic encryption, multi-party computation. It can take actions triggered on events, co-processors, data storage. The scope of what verifiable agents is enormous. The scope of what verifiable agents is enormous. You can just mix and match these services to build verifiable agents. You also can do ID. Like, imagine if an agent is a person, it needs to verify the counterparty that it's dealing with. You need proof of human, proof of device, proof of agent, agent reputation. Each one of these new and interesting layers can be built on EigenLayer. This is one of the reasons we think of EigenLayer as the verifiable commitment cloud. What is the verifiable commitment cloud? Many of you, like I said, maybe heard of EigenLayer as like staking, right? Stakers and operators come together. And now you can build these AVSs on top, and these AVSs serve applications. There's also a layer in the middle we call primitives. You have commitments, verifiable services, verifiable apps. And these apps just come in and mix and match these AVSs. And like I said, agent is just the new app. So if agent is the new app, agents can come and compose these services to build verifiable agents. We also have the core primitives. Like I pointed out, when you want to run an agent, you want to publish DA, publish data to a common verifiable DA. That's what EigenDA is. We also have other very powerful features like eigenforking, which I'm not talking about today. But these primitives together give the expressivity for services to build new and interesting things like these AI agents. OK, so if we look at this picture, so we have many categories of AVSs that agents can compose to build new and interesting things. What are being built today? So, this is a category map of AVSs, autonomous verifiable services that can be built on top of EigenLayer. They're built on top of EigenLayer, and some of them are being built. You see names here. Some of them are not yet being built. So it's a call to action. All of you brilliant developers here, people joke that, oh, Ethereum's infra land. Without these powerful infrastructure, you cannot build, you cannot express the level of agents that we need to build unstoppable, verifiable agents. So several categories here, many, many interesting players. This is not theory land. Many of these AVSs are already being built and deployed on EigenLayer today. Here's a very small sampling of what these services are. Layer Lens, building AI benchmarks. I can benchmark agents. Open Ledger, building data markets. You can buy data. You can sell your data to these agents, which can then pay you for your contribution. Verifiable models being built by Neural Fabric. Event-triggered actions. Sentient, a huge project. We're collaborating with them on building an AI justice system. When you think of smart contracts, you think of what is expressible in simple code. But when you want to build complex contracts, you need adjudication for it. Witness, real-world location. I can actually attest. There's an app by Witness called Infinity Watch. You can go in and prove that you're in this location to a decentralized group of 6,000 nodes running around the world, running today on EigenLayer. Silence, you can actually take your secret key and give it to a network, which gives you guarantees of privacy. Opacity, when a tool call is being made, you are calling DoorDash, you're calling OpenAI. How do you verify these API calls? You can do it today on opacity. So the category of what is being built is mind-boggling. And very few people understand where this is going. It's not just that these unstoppable verifiable agents are interesting on their own accord. They also accelerate the foundations of crypto. How do you think about intents? How do you think about smart contracts? How do you think about governance? How do you think about decentralized science in the presence of AI? It just transforms the entire landscape. I want to end this by saying what we're building at EigenLayer is the verifiable commitment cloud, a cloud where you can make commitments that are verifiable and enforceable by code. And so the project is much, much, much broader than restaking, and I think it can inject a new lease of energy into the Ethereum ecosystem today. With that, I'd like to thank you. And if you want to find more information, please, take a picture of these QR codes. And I'll leave you with this question with fellow inventors here. What are you going to invent? What are you going to build on EigenLayer today? Thank you so much.